All right, we're recording. Athena, you're recording this, right?
Sure am.
Been watching all these lectures as we've recorded. What would you say is maybe the most important thing to do when you get data?
Look at your data.
You got to look at your data. I want to show one more little example. These are a famous data set from Frank Anscombe, and he set up some data sets where all these statistics were true. It's a set of 11 observations, and they have the same mean for X, the same mean for Y, the same regression model, the same sums of squares, the same R squared, but you have to look at your data because your mental image, if I just show you the numbers, is something like this: a nice, neat, linear regression with a linear relationship between X and Y, some sort of homoscedasticity, a hint of normality of Y at each level of X. But those same numbers that we just saw also summarize this picture right here. What do you think about fitting a linear regression to those data? It doesn't make any sense. There's a relationship there, a perfect relationship, but it's not linear. How do you know? You have to look at the data. We've seen this idea of outliers. This is very interesting set of data. Again, those numbers that describe those previous two pictures also describe this one. This is a perfect linear relationship, except we have this model failure. Something is wrong. Well, is it wrong with the point or is it wrong with the model? What's going on here? You don't know. You take this point and you investigate it. You look at everything that you can about it. Maybe this is those bears that we looked at. Remember the length of the bears and the weight of the bears? If there's a perfect relationship between length and weight, and then we see this, well, I think you would ask first, is that a bear? Is it the same species of bear? What's going on there? And we see this other example right here on the right. We see that these points all have the same X value. There's no variability in X, except we have this one guy over here, this leverage point, this influential value. And wherever he is, that's where the line is going to go. If he's up there, he has a high value for Y, then the line will look like this. If he's down here and he has a low value for Y, then the line will go like this. This is not good. You're deriving this equation based on the value of 1 point. So in summary, look at the data. Always look at the data.